Hi.
Here we are on March 21st, the first day of spring. We're very excited. I have lovely people with me now, and we're going to do a little bit of body-mind centering post this series that was finished last Thursday called Transforming Stress into Calm and Chaos into Clarity. Lovely title. Using key embryological structures. So today what I'd like to look at is the septum pellucidum, which is very important for establishing the midline. We started the series looking at the midline, so I'd like to just pick that up. And if you have one of those diagrams that Bonnie included, it's in the last group of diagrams, pictures. So Hella, do you have those drawings?
Yeah, I'm just gonna access it now. Yeah.
Okay, I'm gonna give you some time while I put
It's
some
okay.
pumpkin seeds in my mouth. So I had a dental appointment and my teeth look very clean, so I'm very happy about that. But
Yay.
I have to eat something at the same time.
Okay, yeah. I have
Okay,
it.
so I'm gonna read, or maybe you should read. You have a paragraph in front of you. You can read a paragraph and Kira can read a paragraph.
Okay.
Okay.
The septum pellucidum is a thin, triangular, vertical double membrane containing both white and gray matter. It is located in the midline of the brain between the anterior horns of the left and right lateral ventricles. It extends downward from the corpus callosum and the fornix to the fornix,
yeah.
the hippocampus commissure.
During fetal development, there is a space between the two layers called the cave of the septum pellucidum. It usually disappears in 90% of people during infancy. This space has also been referred to as the terminal enlargement of the spinal cord. It plays an important role in the development of midline, especially between the special sense organs of the face, mouth, nose, ears, and eyes.
Wonderful. So if we look at the drawing, we can see, now I'm not supposed to put the drawing on recording, so I can't really put that up. But if you're looking at it, you can see, you can imagine inside your body, going up the spinal cord. You go up the spinal cord. There's so many things to mention here. As I'm going up, I'm thinking about a lot of things. So I'm going to just go ahead and talk about it. First of all, we have the primitive streak that starts at the perineal body between the openings in the root chakra area. So I'm talking about the vaginal opening and the anal opening. You have that perineal tissue. So from that tissue grows the primitive streak. And that brings you up part way up your center. And then it starts to retreat. As it goes back down, the notochord forms. And the notochord, as you remember, is the central organizing unit of the embryo. So the notochord keeps going up, and the notochord develops eventually into the nucleus propulsus of the vertebrae. And then as it keeps going, you have the development. We could stop and talk about other things, but we'll keep going. You've got the lower brain behind you have the cerebellum in the back. You have the hindbrain, which consists of the pons, the medulla, then the midbrain, and then the pons. It's actually inside your brain. So you have to go inside your brain. If you go through the foramen magnum, and I don't know how much you know about the foramen magnum, but if you just rock your head, your atlas is holding the skull bone. So if you rock you can do a bigger rock, and then as you get smaller and smaller with your rocking, you're on the cups that are formed by the atlas. So it's rocking, so your skull can rock forward and back. If you really focus in, it'll be a much smaller movement. So dig your fingers in the deepest part of your neck in the back, just under your skull, and take a little motion, rocking forward and back. And you're saying yes. And just for the sake of it, you can remember that when you turn your head side to side, you're no longer at the cervical junction of the head to the neck. Once you start turning your head, you're going to the second vertebrae, which is called the axis. And it has an axis in the middle of it called the odontoid process, where the atlas sits and can rotate around that long spike. In a way, it's one way to say it's a spike, but it's a long part of the bone. And you can turn side to side and just say no, and try to isolate your axis. And then you can isolate your atlas. Try to pinpoint the place where the skull rests on the atlas. Okay, so in front of that, you've got your spinal column, meaning the spinal cord. And the spinal cord is coming up, goes through the hole, the foramen magnum. And to see if you can imagine the foramen magnum. It's going to be the base of your skull. And let me get my skull so you can see what that looks like. And then you have the medulla as the first part of the brain. And on the medulla, you have the midbrain, goes to the midbrain. And above the midbrain, you have the pons. Amazing. We also have behind the medulla, you have the cerebellum. So just so you can see, here's a skull, half of a skull. And here's the foramen magnum back here. Here's the inside of the skull.
And the axis that we were rocking on to say yes were those two bumps.
Here are the condyles. Yeah.
So those are cradled in the axis and what create the nodding.
Yes. It should be movement in both the axis and both the atlas. And then the axis sticks up here, and there's rotation. Let me find, I also have that in a bony structure. I never know where I'm going to go with my lecture, so it's fun, but I do have an enlargement of the atlas axis of the first 5 or 6 vertebrae that I got from the Upledger Institute. Unfortunately, I don't have that. So let me just find something on Google. Okay, so I do have something here. I'm going to put on the share so you can see it. I like the way this looks. Let's see if I can get this bigger. Oh, I got the other one. Okay, that's fine. So here you have the cup, the sockets in the atlas. Here you have the transverse ligament that goes around the odontoid process. You see this stick up here. Wow, I don't know why that changes. Let's see. So you see this is here. This is the first vertebrae. Now I want you to notice it's actually quite wide, and we really don't realize how wide it is. But you can feel it, and you can turn your head by pushing one side at a time. It really comes right out to the side of your neck. So Helle, you're not specific on that vertebrae. You're kind of going off the center. Make sure you're really staying vertically on your axis.
Okay, thank you.
That's better. That's better. And Kira, that's good too. And Kira, I would just ask you to think about your atlas now, so it brings your head back rather than having you in front of your central line, without tilting your chin.
Oh.
Just bring it back. Think about, remember she talked about the occipital vertebrae, the somites, the occipital somites forming the tongue.
Yeah.
And I've been playing with that image of the tongue coming from the back where the somites gave rise to them. And that just really, as Bonnie had suggested, would really bring your head back on center. Yes, that's it. That's it. And I can see you don't quite have that image, so you can keep playing with that, work with that.
Yeah, because to me, the tongue coming forward kind of makes me think about the head coming forward.
Okay, so don't think about the tongue coming forward. Think about the tongue rooting in the back where the neck is. Because she talked about it arising from the occipital vertebrae, the somites rather. So think of it coming from way far back behind your throat.
Ah, yeah,
That's better. That brings you back.
yeah.
That
Thank
brings
you.
you back. Yeah.
Yeah.
So this transverse ligament keeps your neck from falling apart. I will say that some car accidents, when you tear that ligament, the transverse ligament, it can be life-threatening. I don't know if you.
Yeah, no stability. And the picture they're showing the rotation, but you said the rotation is happening at the axis, not the atlas.
Yes, they are showing it at the axis. So I'm going to try to find one that shows us.
But you're basically saying those things that are sticking out shouldn't have arrows going side to side. It should be one down from there.
Well, this one is.
Is that part of the atlas or the axis?
This is the atlas. Yeah, you're right. You can grab it and you're turning this here. You're turning your. That's the atlantoaxial joint. You see at the bottom it says the atlantoaxial joint here.
Okay.
So
So
we're
it's moving,
looking,
it's moving with the skull, not moving.
moving with the skull. Since the article will explain in depth how to measure and correct the atlas joints, both at the much neglected atlanto-occipital junction and the more popular atlanto-axial junction. And he's talking about what they consider to be the main exacerbating factor behind atlas misalignment, that many approaches are missing crucial aspects and measurements of atlantal alignment, as well as essential factors that prevent correctives from sticking. Okay, so we go down, we can see a picture here, the occiput here, and you see a lot of ligaments here. And here's your atlas at C1. I don't think that's any better. And here's your axis at C2. Okay. So here we're looking at the arch of the atlas, the dens, which is the name of that bone that sticks up, the ligament that enables a rotation around, shaking the head to indicate no, which is what we're doing. This is our no. And here's the joint that permits the nodding, as in saying yes.
Okay, okay, yep.
Okay, so here we don't see the atlas. I mean, we don't see the occiput, but here you have the skull, the occiput, and these are the surfaces where these are the balls, actually, not the cup is on the atlas. The ball is in the, yeah, well, that's what I was saying. Yeah, so we're rolling here. So it's a very minute, if you really focus it, it's a small movement, I think you were doing, and you think about both the atlas and the occiput moving. So you have both forwardness. When you tilt down, the balls in your skull are moving back. And when you tilt your head up, the balls are moving forward. And the atlas is counter-rotating, you know what I'm saying? So you have this and this. So keep moving both surfaces, the top surface, which is the skull with the ball, and the supporting surface, which is the cup, the two cups and two balls, and that's in the atlas. I'll just have you do the yes movement for now, so I can just check you. And Hella, you're a little far. You're in one position. You've got your chin up, and now you're coming back down. That's it. So take it from that and just do micro movement. That's better. That's better. Now you're on it. And that's it, Kira. Okay, and then let's go down one vertebrae. And here you're moving your head and your atlas around the axis. But now take your fingers and push on when you find that knob. If you can really feel that's, wow, that's definitely the outside portion, the transverse process of these first cervical vertebrae.
So it's just below, I'm not palpating that, what you're saying, that transverse process. So it's just below the ridge of the cranium.
Now it's not just below. I can stick a whole finger width in there, the tip of my
Okay, that's
finger
right.
before I get to it. Yeah.
Okay. I'm
I
going
come down a little bump. I mean, that's my experience. If you look at it from the front, I'll show you, you can go inside your mouth. If you have a mirror and a flashlight, you can look inside your mouth and see if you see the bump of your atlas. I had the pleasure of seeing a nose, throat, ENT, ear, nose, throat doctor. And I said, is this my atlas? Is this my atlas? And I opened my mouth. Let's see, can you see this? Go closer, closer, closer. I just see that bump. See it sticking out?
Oh, yeah.
Yeah.
Can you find yours?
And try on my phone.
Yeah, you could take a picture of it and then blow it up and see. You need to turn your flash on though.
Yeah.
Oh, here comes Barbara George. Hi, Barbara.
Hi, sorry I'm a little late. I just saw the email.
Oh, it's so nice to have you.
Thank you. It's nice to be here. Yeah,
You're
I'm glad
doing-
to have caught you.
That's great to have you. We're doing the atlas and axis rotation right now, and we're looking at the front of our throats inside to see if you can see. I think you were in the class when I did this before, right?
Yeah, I
You
was. I
see-
think so.
I didn't. So they're locating the atlas from the inside of the mouth.
Oh, cool. Yes. Okay.
We started by talking about the spinal cord coming up. We isolated that picture in that Bonnie sent out of the septum pellucidum. Do you have your drawings by chance?
I have access to them right now. Yes, but all my printouts are
Well, we're hoping to get up to the septum pellucidum, but
great.
we got waylaid by the atlas axis.
It was so
Fun,
cool.
fun stuff.
Fun stuff. And I was talking about the foramen magnum here. And we're trying to locate the foramen magnum, and you have a lot of ligaments that attach there too,
Wow. Yeah. see
which I
that.
describe in my book. So if you happen to get a copy of my little book, you'll see a description of the ligaments that connect to the foramen magnum. I think it's the anterior posterior ligament. My little book.
Oh, wonderful.
And talk about this. The ligaments. Oh, I even have a picture,
Oh, right.
which I think is from Gray's Anatomy. The two longitudinal ligaments in your spine. You aware of the longitudinal ligaments in the spine? There's one in the front and one in the back. And it keeps the spine from collapsing. It keeps that verticality going. The anterior is in the front of the spinal column, and the posterior ligament is in the back of your spinal column. So those ligaments, when you get in touch with the ligament, it affects the whole body. So if you think about a line that's in front of the spinal cord and attached to the lining inside the spinal cord, it brings you right up. And you can think of it in the back also. I think it's the one in the front that attaches to the anterior portion of the foramen magnum, so that that line, that rubber band, comes up the spinal cord, in front of the spinal cord, and goes to the front of the foramen magnum. So you find that moment, and then if you continue upward, you'll get to different parts of the brain. Let's see if I can find pictures of that so that you can see it more clearly. Go to, you can look on your drawing and you see they're not labeled, but at the very bottom, what is that? What is the smallest? You have to use this, because if I don't use it, I can't teach it. I'll stop the share. I'm going to come back to here. So here we have this line coming up. Well, what is this?
Spinal cord.
That's the spinal cord, exactly. So you come up the spinal cord, and then what is this structure?
Medulla.
That's the medulla. And then you come up here.
Pons.
That's the pons. And we come up here. What do we have? Midbrain. And what is this openness here? This funny shape. Yes, and which ventricle is that?
Third?
And that's the fourth.
Fourth.
Fourth ventricle. And then what is this structure?
Cerebellum.
The cerebellum. And we keep going up. Remember that Bonnie thought that the pons and midbrain are actually extensions of the spinal cord. And she must mean the medulla as well, medulla and pons. If these are extensions, you can see why that would be. And as you keep going up, what is this structure?
The thalamus.
That's the thalamus. And then if we go a little bit forward, here, what is this structure?
Hypo.
The hypothalamus, right? And then, so we want to do this in our minds now. This green structure is, what is the green? Yeah, the commissures are connecting the sides, connect the left and the right of any structure that, you see any commissure, that means it's connecting the left and the right sides. So this is a commissure. It's a little unclear about how that works in this picture, but that's okay. So, and right here, what is this structure? The orange.
That's the one with
Septum pellucidum.
That's the septum pellucidum. That's where we're headed. That's where we're headed. So let's pick up where we left off at the greater foramen, which is around here. And let's see if you can find it in yourself that you're in the front or in the back of your foramen magnum. And then you're going to go up to the medulla. And then from the medulla, you're going to go to the pons. And then from the pons, you're going to go to the midbrain. And now the part of the midbrain is the wall is the midbrain. I have to check on that. no, I think it's a hypothalamus, forms the wall, one of the walls of the third ventricle. So if we follow the fourth ventricle, the cerebral aqueduct to the third ventricle, and then they're not pictured here, but you have the lateral ventricles. So this second and first, but they call them the lateral ventricles. And in between that, you have this septum pellucidum. That's where I want to think right now with you guys, or feel, embody. So we're traveling up. We've got to the pons, and then the midbrain. And this is where we did that folding. We did the folding from the midbrain. We think about embryologically the heart. The heart is coming over the midbrain, and we bow from the midbrain. At this point, we think also of she didn't really talk about it this time, but we do have the growth of the cerebrum coming back up and lifting you into vertical, more vertical. And we can think of that as the lamina terminalis, which is the top of this column, and it grows, sprouts up the cerebrum, so that you've got the cauliflower from the lamina terminalis. And then it widens your perspective. But before you get to that cauliflower forming, I want you to stay into the septum pellucidum. And if you read the structure, it has a double membrane. And if you can go into this small area, which is that triangle, behind your midbrain, behind the bridge of your nose. And you take your hand and press them together to find this midline of your body. And I would put the palms together to really have that line. And then if you create a millimeter of space or 2 millimeters of space between them, that'll be the cave of the septum pellucidum. She talks about this. The cave of the septum pellucidum is a space between the two layers, the two membranes, which usually disappears in 90% of people during infancy. It plays an important role in development of the midline. So I want you to think about how you feel, experience that space between the two leaves of the pellucidum septum before they disappear, if they happen to disappear, and see if you can find that and feel that the water there, the fluid there, the space there. And because you're really close to, it's not part of the ventricular system. It doesn't have the choroid plexus inside of it, but the space is, it may have fluid, and I feel it's definitely, I don't know if it's filled with, I feel it's filled with something, but I don't know if I don't think it's salt water, but it feels lucent. So light can pass through it. So if you have that experience, go for it. Feel whatever you feel. And there's your foundation for the midline. So I would play with my hands coming together so the space disappears, see what that feels like. And what I notice is I suddenly become more aware of the olfactory bulbs, one on the left, one on the right. And then you have the cranial nerve 13, which is also about smell, but more about the smell of the body that attracts you to somebody, or their body that attracts them to you. That's the olfact. That's cranial nerve 13, which is lying right next to the olfactory nerve. Number 1, it's first cranial nerve. So just play with the separating of your hands and the pressing together. And then feel free to move your whole body with that sense. And we could add the feet because our tone starts from the feet. So we could start pressing into the floor with our feet, coming up through the primitive streak, up through the notochord, up into the spinal cord, following that up into your brain, all the structures that we discussed, through the foramen magnum, we've got the medulla, and then we've got the pons, and then we've got a midbrain. We can fold from the midbrain, come up to the thalamus. A little forward is the hypothalamus, and down and above is the epithalamus, where the pineal gland is. And we can find the septum pellucidum. Above the thalamus. And under the corpus callosum. So it extends downward from the corpus callosum to the fornix. And it's connected with by the hippocampus commissure. That is the fornix. And if you care to go in the other, then, you know, and what Bonnie did in the first class of this last winter series was about the midline. So you can add, if you want to go more, but I think this is just fine what we've done. But we did do movement with the brain, cells to brain and brain to cells. But I love this little septum pellucidum. It's like a triangle of power, of meaning, of mystery even. But it's like an arrowhead shape. So it feels very ancient and directional, gives direction.
Is it upward facing or
Yeah.
upward?
Yeah. The vertical double membrane containing both white and gray matter. Located in the midline of the brain between the anterior horns of the left and right lateral ventricles. You know, it's also interesting to me because there's a section of bone in the nose. It's also vertical, where there's, I think, an attachment of the tentorium, which is the membrane inside the skull, one of the membranes encases the cerebrum and attaches to this little, the tip of this bone, this also in a vertical plane. So it reminds me of that. Well, these little mysteries that we have hidden, not so hidden in our brains, that we can discover with Bonnie's expertise. So, do you have some comments that you want to make before we close?
Yes, so can I just ask a really, it feels maybe you covered this in your study group. Can you point on the image where the foramen magnum is on the image?
Oh, no, it's not in the image.
I know, but can you just point where it would be?
where it would be. Okay, I'm not supposed to use the image, but here we go. It's
Oh,
impossible to
okay.
teach with it.
Down then.
It's at the
Down there.
base.
It's at the base there.
The
So
base,
everything.
the brain is inside. The spinal cord comes up here. It's right about where the spinal cord enters the brain. I mean, the
Okay.
spinal cord goes through the foramen magnum and becomes still a little bit of the brain, but it's really going right into the medulla.
Okay,
And then
thank
the
you.
cerebellum is in the back. Thank you, Bonnie. That's your drawing. Thank you.
Yeah, thank you, Bonnie. Thank you so much. This has been really interesting. I don't think I found it, but I'm
Yeah, play with it. Play with it. You
Right.
know, look at that picture and then say, oh,
Yeah.
where is that in my head? And
yeah.
yeah. Where are these structures?
I found
mean-
the, oh,
Mm.
go ahead.
Good.
Septum Pellucidum exploration was really fantastic. I rewatched the first class last night, and about like where she talks about finding the midline and how we can become so tight in our spine, and like as soon as we went to that space, it's like I've practiced finding the midline, but just opening up that space, like I could feel all the muscles down my spine just kind of like give me space all the way down.
That's beautiful.
So that was so awesome. Wonderful practice. Thank you,
Wow.
Sarah. I'm sad I missed the rest of the class. But I'll have to find your book and
Okay, you can read about it. I have a recording of most of the class, so I can send that to you.
oh, amazing. Thank you.
Okay.
Thank you, Sarah.
Yeah, thank you so much.
Thank you, guys. Wonderful to have you, and we'll meet next Thursday. Is that okay? Okay.
Yeah.
Thank
Yeah.
you.
Thank you. Bye.
Feel free to write to me. Barbara, let me just make sure that I've got you've got my email. So obviously Sue was supposed to come. I don't know why she couldn't come. Let me just have your phone number, Barbara.
It's 717
Mm-hmm.
855
Mm-hmm.
8501.
Okay. Thank you, thank you, thank you. I'll see you next Thursday. If you're not coming, let me know, okay?
Okay.
Okay.
Thank
Bye-bye.
you.
All the
Bye.
best. Enjoy your midlines.
I might have to do it from my car next week because I have a 4 o'clock appointment that's a half an hour away. So I'll have to
Okay.
figure. Okay.
Okay. Nice to see you, Kira.
See you again.
Thank you.